Today, let's talk about WhatsApp.
You know those chat apps you use like 100 times a day? We fire off messages without even thinking about it. But have you ever stopped to wonder what's really going on under the hood? Because what we're talking about here is an absolute engineering marvel. These systems are juggling hundreds of billions, yeah, billions with a B, of messages every single day. It's this huge invisible machine connecting all of us in real time.
So let's do this. Let's follow one single message on its epic journey. We're going to trace its path from your thumb all the way to your friend's screen.
Okay, so you hit send. It feels instant, right? Almost like magic. But it's not. That little message of yours has to go on a surprisingly complex trip to get where it's going. So where does it actually go first? Well, the very first thing that happens is your message zips up to the cloud. But it doesn't just show up anywhere. It has to go through a very specific, secure front door. We call this a gateway. You can think of it like the main entrance to this huge digital post office.
Now, here's the clever part. The gateway itself is kinda, well, dumb. And that's on purpose. Its only job is to handle the connection. It has no idea where your friend is. So to figure that out, it has to ask someone else, a different part of the system that acts like a digital switchboard operator. And that's called the sessions service.
And this session service, it's absolutely crucial. Its whole job is to keep a live, constantly updated map of everyone. It knows exactly which user is connected to which gateway at any given second. So it knows you're on gateway number 1, and hey, your friend just connected to gateway number 2. It's basically the traffic controller for the entire system. So the session service gets the request, it checks its map, finds your friend's gateway, and pings it, saying, hey, I've got a message for this person. Then that gateway sends it down to their phone. Simple, right? Well, there's a small problem here. See, the way your phone usually talks to the internet is with something called HTTP. Think of it like knocking on a door. You knock, which is the request, and the server opens the door and gives you what you asked for. The server can't just randomly open your door and shove information at you. So how on earth does the message get pushed to your friend's phone instantly? The magic trick here is a technology called WebSockets. Instead of that one-way street, WebSockets create this persistent, two-way, tunnel, basically. It's like an open phone line between your friend's app and the server. This allows the server to instantly push the message down that tunnel the moment it gets it. That's what makes it feel so real-time. Okay, so let's bring this back to something you see all the time. You know those little check marks, the single tick and the double tick? Well, they're not just for decoration. They're actually telling you exactly what's happening in this back-end journey we just talked about. Think about it. When you hit send, that first check mark pops up. That's the server, our session service, saying, okay, I've got your message. It's safe with me. That's tick number 1. The second tick, that doesn't show up until the message has gone all the way to your friend's gateway, down to their phone, and their phone has sent a little delivered signal all the way back. It's a complete round trip. Pretty cool, right? All right, so messages make sense now. But what about that online status, or last seen at 2:15 p.m.? How does the app know that? Yep, you guessed it. That's another really clever piece of this whole puzzle. There's yet another dedicated little service just for this one job. Let's call it the last seen service. And all it does is log a timestamp every single time you actively do something. Send a message, timestamp. Read a message, timestamp. Any direct action from you gets logged. But here's a key distinction. Not all communication is the same. Your app is probably chattering with the server in the background all the time, right? Just checking for stuff? The system is smart enough to know the difference. It only updates your last seen status when it's you actually doing something, not just the app doing its behind-the-scenes housekeeping. And the logic for showing online is actually super simple. The system just has a rule, like, if this person's last activity was less than, say, 15 seconds ago, don't even bother showing the time. Instead, it just flips the switch to online. That's it. Okay, now for the real challenge. One-on-one chats are one thing, but what happens in a group chat? How does one single message get to, 100 different people all at pretty much the same time? This is a huge engineering problem, and it's called the fan-out challenge. You guessed it. There's another microservice for that. It's called the group service. Its only job is to be the bouncer, basically. It keeps the list of who's in every group. So when you send a group message, the session service asks the group service, hey, who's in this chat?
The group service sends back the list, and then the session service gets to work, sending a copy of your message out to every single person on that list. That's the fan out. And that brings us to this number. You ever notice how most chat apps have a limit on how many people can be in a group? That's not a random number they picked out of a hat. It's a very deliberate engineering decision. Trying to fan out a message to thousands or millions of people instantly would just crash the system. That limit is what keeps group chats feeling fast and reliable for everyone. So, when you put all these pieces together, how does a system this big, handling so much traffic, not just fall over and die all the time? Well, the answer is that it's built from the ground up to be resilient. It's all based on a few key ideas. First, all those little services we talked about, that's called a microservices architecture. It means that if the last seen service breaks, for example, you can still send and receive messages. The whole system doesn't go down. Second, it uses things called message queues. So if a service is busy, the message just waits in line safely until it can be processed. And during crazy traffic spikes, think New Year's Eve, the system gets really smart. It'll actually delay less important things like updating read receipts just to make sure the number one job, actually delivering the message, gets done. So, if we zoom out and look at the big picture, it all boils down to three main ideas. First, decoupling, breaking everything into small, independent parts. Second, real-time communication, which is all thanks to WebSockets. And third, resilience, building a system that expects things to fail and knows how to handle it. That's the secret sauce. So the next time you fire off a quick message, maybe you'll think about that incredible, invisible journey it's taking in just a fraction of a second. And it kind of makes you wonder, doesn't it? What other amazing engineering marvels are hiding just beneath the surface of the other apps we use every day?
Thanks for digging into this with me. Until next time, stay curious.